చదువుతున్నావమ్మా ఇక్కడికి వచ్చి కూర్చో రాని వర్డ్స్ అడుగు ఇక్కడికి వచ్చి కూర్చో నుంచి ఇక్కడ వరకు ఉండే పదాలన్నీ చదువు రాణిని వెంటనే అడగాలి. వేర్ ఆర్ వి spherical mirrors, image formation. So we have seen at point C, beyond C, center of the curvature, between center of the curvature and pole, and what is the page number? So how can we represent this using ray diagrams? Okay, we are representing this images whatever are forming through whatever the forming image through spherical mirrors. Come here, Varshita. నువ్వు కూడా ఇక్కడ పృథ్వీ దగ్గర కూర్చో, ఈ చెట్లు నాకు అవి ప్రాక్టీస్ అయిపోగానే చెప్పు అనుశ్రీ, నేను క్లాస్ తీసుకుంటాను. Through spherical mirrors, how the image is forming, you have seen yesterday. Okay, did you remember at infinity, Divya, what is the position of the image at infinity? Don't look into textbook. Position of the image. I told you yesterday you should buy had this table. At infinity, what is the position of the image? Very good. Clap to Abhiram. Yes, at beyond between C and F, Mirpat. You in your textbook also it is there. Yes, at between center of the curvature and focal length, where the position of the image, what is the size of the image, what is the nature of the image. Let Mirpat tell. Position of the image is beyond C. What is the size of the image? Did not study. Real and in all cases, remember, at infinity, beyond C, at C, between C and F, and at F. Okay, in all these 5 cases, the nature of the image is real and inverted. Real. Inverted in the sense your right hand will appear as left hand. Your left hand will appear as right hand. Inverted meaning is that when you look into the mirror, Abhinav, are you listening? Yesterday you missed the class. Concentrate, more concentration on my words. Okay, be active. I will be asking questions. If you are focused, you can answer. Otherwise, it is difficult. I told you at the beginning only. Yes. So, in all these 5 cases, what are the 5 cases? At infinity, beyond C, at C, and between C and F. C and F, at F also. In this all 5 cases, image formation, nature of the image is real. Okay, how we are appearing in the mirror? Same, like that, real only. Okay, we appear real only, na? And inverted. Is your right hand in the mirror? No, it is left hand. Okay, is your ear, right ear is right ear in the mirror? No, it will become left. Okay, inverted meaning is that one. Okay, inverted meaning is ice cream. That. Okay, only at between P and F, pole and focal length is there now. That time it is virtual and erect. Virtual means reverse. It will be reverse because it is very close now. Focal length and pole is very near. That is why that nature is virtual and erect. Erect means straight. Erect means straight. Okay. So position you will come to know. You have to by heart this table. You have to by heart this table. I will ask you. So now representation, if you see, representation of images formed by spherical mirrors, by ray diagrams you can represent. How will you represent spherical mirrors image? Spherical mirrors image. Okay, image formation. Whatever the image is formed, how can you represent it? With using ray diagrams. Okay, ray diagrams. We can also study the information of images by spherical mirrors. We can also study the information of images spherical mirror by drawing ray diagrams. Consider an extended object of finite size placed in front of a spherical mirror. Okay, you take one finite size object. Okay, any object, finite size object you take and you place it in front of the spherical mirror. Are you clear? You are taking one finite object and you are placing in front of the spherical mirror. I am not saying concave or convex. What mirrors first we are going to study, we will come to know. Okay, each small portion of the extended object acts like a point source. Whatever this object is there, na? Okay, you can imagine any object that each portion of the extended object, each portion in the object, suppose imagine this book, okay, it is placed in front of the spherical mirror. Each position, whatever is there in this object, each position, okay, each position will appear in the spherical mirror, right? Each position, small portion, okay, of the extended object will act a point, will act as a point source. Okay, an infinite number of rays originated from each of these points. So each and every portion will act as a point source. I am telling point source. That infinite number of rays will originate from each of these points. There is not only one ray, not only one ray will originate for each point. There will be infinite. Infinite means countless. Each point, this is the textbook. Okay, each and every portion, small portion also will act as the point source. From that, many rays will originate. Not only one ray, many rays will originate. Okay, so that many rays, whatever originated from each of the image of an object, an arbitrarily large number of rays emanating from a point could be considered. However, it is more convenient to consider only two rays for the sake of the clarity ray diagram. Okay, there are n number of, there is particular number is not there. From each point there will be number of rays are originating. Okay, but for the sake of understanding our understanding, we are considering only two rays. There are many rays are originating from that point, but I am considering to understand the image, the size, how it is formed. To understand that one, I am just taking the only two rays. How many rays I am considering?
Two rays.
Two rays only I am considering. Why I am taking only two rays? There are number of rays are originating from each point, even though I am taking only two rays. Why? Because to understand the image, how this image is forming, just to understand that. Okay, so it is more convenient. Okay, just for our convenience only. Okay, for our convenience only I am just considering two rays. These rays are so chosen that it is easy to know their direction after reflection from the mirror. So again, whatever these rays are falling on the mirror, they are getting reflected, na? So to understand this reflected rays also, are you getting my point? Are you following me? Are you following me? Just I am taking this book as image. I am placing this book is in front of a mirror. Okay, there are many small points are there. From this portion I am considering only small portion. Okay, small, each portion will act as a source of the rays. Okay, okay, there are many n number of rays are originating. Okay, there are n number of rays are originating from each and every point, okay, of this entire textbook. But to understand, to our convenient, to get the clarity how this image is forming, I am taking only two rays which are falling on the mirror. Okay, there are many rays. Are you getting my point? There are many rays, but I am considering two rays that are falling on the mirror. Again, this incident rays will be reflected rays. It will become reflected when it fall on the mirror, no? When it fall on the mirror, again you keep your hand like this, Abhiram. Here, you keep your hand like this. Yes, this is the mirror. You imagine. You keep like this. Like this, like this. My side, huh? This is concave mirror, right? This is concave mirror. So this I kept this image in front of this mirror. So there are many rays are originating from small portion. They are falling on the mirror. That this falling of rays are incident rays. Again, when they fall on that mirror, they will be reflect. No, each incident ray will be reflected. So to understand that reflected rays also, I am considering only two rays. Okay, so again here first the intersection of at least two reflected rays give the position of the image point. Okay, where the image is forming. Here we have studied the table where that image is forming. Okay, I am just using with ray diagrams. I am showing that image in this ray diagrams. Here we learnt, but using the ray diagrams, I am showing the image where it is forming. Are you getting? Okay. So the intersection of at least two reflected rays give the position of the image of the point object. Any two of the following rays can be considered. See here there are two rays. There are two rays. There are two rays, two mirrors, concave mirrors, convex mirrors. In the first A diagram, they are showing the concave mirror. See in the diagram, concave mirror it is. In the diagram B, it is convex mirror. It is bulged, no? Convex mirror. In the first case, two parallel lines. You see here, these are the two parallel lines. These are the two parallel lines. Means those are originating from the image. Originating from image. అంటే image నుంచి వస్తుండే rays అది. Okay. I am considering only two rays now. Why I am considering only two rays? Because to understand, to our convenience, to our clarity. Okay. To show the image formation. To show the image formation. Okay. Those two rays are falling on the mirror. Are you seeing in the diagram? Look at into diagram. That two rays are falling on the mirror. Again they are getting reflect. Okay. They are getting reflect. Okay. So if you see here, in the case of above line, parallel line, it is forming, that image is forming reflected ray. This is incident ray. Okay, incident ray. Reflected ray is at focus, at F, at the focus. At focus. These are the two rays which are showing. In the second case, convex mirror, reflected ray. Even that is also, if you extend it at focus, it is forming. A ray parallel to the principal axis after reflection will pass through the principal focus in case of concave mirror, or appear to diverge from principal focus in case of convex mirror. In case of concave mirrors, you see first one, okay, in this diagram, if you see first ray, you look at me on my finger. Okay, this is the ray falling in the on the concave mirror. Concave mirror. This is reflecting principal focus. If you see reflecting, it is arrow marks you observe. It is coming like this and going like this after falling on the mirror. Okay. So where it is passing through? Through the principal focus. Through the Principal focus. F means principal focus. I told you na. Okay. This is in case of concave. Concave. This is concave. Okay. In case of convex mirrors, okay, it is diverge. Means it is going back. It is coming like this and going back. It is divergent in case of convex mirrors. Okay. From these two diagrams, what you need to understand? The image formation is at principal focus. Reflection only will see the image now. Okay. At focus. Next, if you see, a ray is passing through principal focus of the concave mirror, or a ray which is directed towards the principal focus of the convex mirror after reflection will emerge parallel to the principal axis. If you see here, in case of concave mirrors, okay, in case of concave mirrors, okay, principal focus. Suppose if the ray is passing through, you need to understand ray diagrams. It is very important. A ray is formed. A ray is, suppose in the first case, ray is passing through parallel to the principal axis. This is the principal axis. First one is principal axis. This is the ray passing. This is principal axis. What is mean by principal axis? Principal axis, one ray is forming through center of the curvature, focal length and pole. Okay. That is the ray principal axis. Okay. So one ray is falling parallel to the principal axis. That image will be at the focal length F, principal axis. Now one ray is passing through a principal focus. If you see in the second diagram, one ray is passing through F, principal focus. Before, in the first image, parallel to the principal focus. This ray is parallel to the parallel it is passing. That image of reflected ray is passing through the focal length. But now it is that ray is passing through the principal focus. One ray is passing through the principal focus. That will again, in the case of concave, or a ray is directed towards the principal focus in the convex mirrors. After reflection will emerge parallel to the principal axis only. After reflection they are coming in the parallel direction. You see, it is coming in this way and parallel to the principal axis, principal focus. It is parallel only. Okay. In the case of concave mirrors. In the case of convex mirrors, it is behind, it is backside. Convex mirrors, image formation will be. So this is falling like this. Okay. Suppose you see the arrow diagrams where it is forming. Arrow will be towards the mirror. Okay. Another ray is passing through the principal focus. In case of convex mirrors, how it is reflecting? It is parallel to the principal focus. Parallel. It is falling like this, it is going parallel. Both are going parallel only. Parallelly they are reflecting. After reflection, how they are going? Rays parallel to the principal focus. Read these 2 points, get clarity. If you are in confusion, I will explain again. It is important, that is why I am saying. Yes. Labeling నేర్చుకున్నావా? మంచిది. నువ్వు పైకి ఎక్కువ. एकरम 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 ఏడమా. మీకు కన్ఫ్యూజన్ ఉంటే ఇప్పుడే అడగండి, ఇప్పుడే అడగాలి, చదవాలి. ఫస్ట్ పాయింట్ సెకండ్ పాయింట్ రెండు అర్థం కావాలి. ఫస్ట్ మీకు రే ఎలా వెళ్తుంది? ఫస్ట్ కేసులో పార్లల్గా వెళ్తుంది. పార్లల్గా వెళ్ళినప్పుడు రిఫ్లెక్టెడ్ రే ఎలా వెళ్తుంది? ప్రిన్సిపల్ ఫోకస్ మీదుగా వెళ్తుంది. చూడండి, కనిపిస్తుందా? డయాగ్రామ్లో కనిపిస్తుందా? అది అడుగుతాను ఇప్పుడు ఒక్కొక్కరిని ఎలా వెళ్తుందనే చెప్పాలి నాకు. యదా 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 ఏడవ 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 ఏల 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 ఏమనగా ఏమనగా ఏమనగా. అమ్మా, did you read? Say Abhiram, what is the first case? Principal focus. Principal focus. Where the reflected ray is going through? It is passing through principal focus. It is passing through principal axis. This is axis, the line which is going through the center of the curvature and pole. One line is passing through the center of the curvature and pole is called principal axis. That one line is going through. I am considering two lines now. One line is passing through the principal axis. Okay. Another line is falling. Another line is going through the parallel to the principal axis. Two lines. Another line is parallelly. They are moving parallelly. Okay. This reflected is going through reflected ray. Principal focus. Okay, with the line which is passing through the principal axis parallelly, that line reflected is going through the principal focus. Okay, in case of concave. In case of convex, diverge. Okay. Aidava, it is diverge. In case of diverge from the principal focus. Okay, it is not passing through the principal focus, it is diverging. going back. Okay, diverging. What is the second case, Divya?
In a concave mirror, array passing through principal.
Through the Aidava over Gada. But in case of second case, principal focus, it is passing. A ray is directed towards the principal focus of a convex mirror. After reflection, where it is going through? It is emerged. It is emerged. Okay. Next, third case, if you see, in the third case, a ray is passing through the center of the curvature. In the second case, through the principal focus. Both are getting emerged. In the concave mirror, in the convex mirror. But in the third case, center of the sea. A ray is passing through the sea. There are many rays. N number of rays are originating from the object points, right? Okay. One is parallel to the principal axis. Second one is through the principal focus. Third one is through the center of the curvature. Through the center of the curvature. A ray is passing through the center of the curvature of the concave mirror or directed in the direction of the center of the curvature of the convex mirror. After reflection, reflected back along the same path. Both the mirrors, both the mirrors, concave mirrors and convex mirrors, if the ray is passing through the center of the curvature, they are coming back in that same path. Reflected rays are coming in the same path. If you see arrow mark, forward direction, backward direction, same line. Are you seeing? You should represent that in the diagrams. Forward direction is in this. Again, same line is having backward direction also. Same. Are you sure? In the same path it is coming. When the ray is passing through the center of the curvature. Center of the curvature. Okay. Rangam. Are you clear with these three? Yes. I will ask you once again, Abhinav. Are you clear with third point? Yes. Okay. Is reflected back along the same path. Okay. The light rays come back along the same path because incident rays fall on the mirror along the normal to the reflecting surface. Why this is happening? Okay. The light rays, whatever are there, light rays come back along the same path because the incident rays fall on the mirror along the normal to the reflecting surface. Whatever the reflecting surface is there, along that only this incident rays are falling. That is why they are coming in the same path. Pata. Next. Third case. Fourth case. Okay. Fourth case. A ray incident obliquely to the principal axis towards a point P on the concave mirror or convex mirror is reflected obliquely. The third one is a ray incident obliquely to the principal towards a point P. Now in the fourth case, P, pole is there now? Pole, center of the sphere. Through that it is falling. Okay. A ray incident obliquely to the principal axis towards a point P on the concave mirror or convex mirror is reflect obliquely only. The incident and reflected rays follow the laws of reflection at the point of incident, making equal angles with the principal axis. You know laws of reflection. Okay, if the incident ray is falling with 60 degrees even, reflected ray will be move with 60 degrees only. The angle of the incident ray is equal to the angle of the reflection. You know this one, na? Abhinav is sleeping. Angle of the incident ray is equal to the angle of the reflected ray. Suppose if the ray is falling with 50 degrees, with the same angle it will be reflected. Whenever a ray is passing through the pole, the angle of the incident is equal to the angle of the reflection. In both cases, concave as well as convex mirrors. Are you clear with this? In the first case, parallel to the principal axis. It is reflecting through the principal focus. In the second case, it is passing through the principal focus. It is passing through the principal focus, and it will reflected ray will be parallel to the principal axis. In the third case, okay, it is passing through the center of the curvature. It is passing through the center of the curvature. Same reflecting ray will also move same direction. In the fourth case, it is passing through the P. With the whatever the angle is incident ray, reflected ray will also come back with that same angle if the ray is fall on the pole. Are you clear with this four? Bara. Yes. Remember that in above all cases, laws of reflection are allowed. At the point of incident, the incident ray is reflected in such a way that the angle of the reflection equal to the angle of the reflection incidence. How much angle it is falling, with that same angle only which it will come back. Laws of reflection will follow in all the cases. Okay. So here at the pole, what is happening obliquely means it is not parallelly, it is coming obliquely through the pole. Okay, this is principal axis. Obliquely it is coming and falling on the pole. Obliquely it is coming back. Okay. Avatala. Okay. Are you clear with this four topics? Huh? Yes. Now image formation by concave mirrors. Okay. Here we have seen ray diagrams for the formation of a concave mirror by various positions of the object. Okay. Same that only they have just illustrated with the diagrams. Okay. See in the first case, Amma. See in the first case, there are two rays, they are falling with principal axis. Are you seeing principal axis? What is principal axis, Amma? What is principal axis? A line is passing through the center line. See the center line? A ray is passing through the center of the curvature and pole is called a principal axis. I am considering two rays. Okay, two rays I am considering for my convenience, for my understand, for my clarity. I am just considering two rays. These two rays, above ray and below ray. If you see the incident ray, this is first one is arrow mark is on the concave mirror. This is concave mirror, na? Concave mirror. It is falling here. It is passing through the principal focus. Are you seeing? It is passing through F. Again, another ray is also parallel to the principal axis. It is falling on the principal focus. Okay, so this you should show. Where this is the image formation at infinity. See, at infinity, the position is at the focus. Where the position is? At the focus. You should show that at the focus. At that time it is highly diminished. It is point size. It is point size. When the rays are parallel to the principal axis. When they are parallel to the principal axis. Okay, when the rays are parallel to the principal axis, okay, at infinity position. At infinity, position is at infinity. Where the image is forming? Once you check. Where the image is forming? At focus. At focus. The image is highly diminished. The image is highly diminished and real and it is inverted. The nature is real and inverted. Okay. Next, if you see in the B case, okay. Next, this line is incident ray. This is incident ray. Okay, A to M. Mn is radius, na? Mn is what? Radius. Mn means that is the sphere size. Okay, Mn. Okay, so here it is falling on the concave mirror parallelly. Suppose next, and it is also forming, it is going through the center of the curvature. See arrow diagram, it is falling through the center of the curvature. If that ray is passing through center of the curvature, again it will move back only. Directions are both the sides, you see. It is falling through the center of the C and it is coming back in the same direction. We have discussed this one now. Whatever we discussed that we are showing in the diagram. That's it. Okay. If this parallel, both we are showing actually. Parallel, if it goes, it will go through the principal focus. If it is falling through the center of the curvature, then it is going back only. In the third case, what is the third case? Third case. Principal focus. Already third case is what, Amma? Center of the curvature we discussed already. Principal focus. Principal focus. A ray is passing through the principal focus. This is the ray. This is the ray which is passing through the principal focus. How it is coming? Parallel to the principal axis. Coming back with, see the arrow diagrams. Okay. It is falling through the principal focus and coming parallel to the principal focus. Principal axis. Okay. Next. In case of, again, this is this. In the D, if you see, in case of fourth case, can you identify where that ray is falling? Can you identify? See, it is falling through the center of the curvature. With that same angle only it is coming back. Right? That image is formed at A. Image is formed at A. Next. At infinity position, suppose at infinity position, if the ray is falling through the center of the curvature, it is coming back in the same direction. In the D case and E case, both are center of the curvature only. Focus is representing in all cases. If the ray is parallel, it is coming through focus. They are comparing with that only. In all the cases, they have given focus. Next, if the incident ray is through the focus length only, it is coming back with the same direction. In the F case also. We are just changing the positions in all cases. Only we are changing the position of the image. Where the image is forming, we are observing. You need to practice this, okay, where the image is forming with the help of the table. So if you are coming for uses, concave mirrors are commonly we use for torches, searchlights, vehicles headlights, okay, to get powerful parallel beams. Okay, they are often used as shaving mirrors to see a larger image of the face. The dentist use concave mirrors to see the large images of the teeth of the patients. So large concave mirrors are used in concentrate sunlight to produce heat in solar furnaces also. This is about concave mirrors. Once study the uses are very important, and practice the diagrams once. If you have any doubts, ask me in the drawing the diagrams. Read the uses. Tomorrow we will discuss the convex mirrors. Tomorrow is very important class, Amma. This mirror formula is there, magnification. Tomorrow in the sense Monday. Okay. Convex mirrors, sign convention, very important topic. You will get definitely problem in this topic. I will finish off the first part of the light. That is reflection. On Monday I will complete it. On Monday I will complete now. So by next Sunday you write a test on light. Tomorrow you are writing bio test. Did you read yesterday? No. Today only you have time. Go through the 81 questions. Okay. Next Sunday I will keep test on light only. We will finish off this refraction Tuesday, Wednesday, Thursday, Friday, Saturday. 5 days. In that 5 days we will finish off the refraction. So we will be finished off most important topic of light. We will be అన్ని క్వశ్చన్స్ వద్దమ్మా, నేను ఇస్తాను కొన్ని క్వశ్చన్స్ అన్నీ రాయడానికి చాలా టైం పడుతుంది. కా అంటే డా రాసావా? ఫస్ట్ ఈరోజు ఫస్ట్ ఇట్లా చిన్న చిన్న పదాల్లో అవుట్ ఆఫ్ అవుట్ తెచ్చుకోవాలి. బయోడయాగ్రామ్స్ చాలా బిజీ అయిపోయింది. అస్సలు ఉన్న వర్క్ ఇట్లా టైం అస్సలు కుదరట్లేదు. ఒకసారి ఇది కరెక్షన్ చూడండి. హాయ్ రోలెక్స్, గుడ్ మార్నింగ్. గుడ్ మార్నింగ్. ఈవినింగ్ లైవ్ ఉంది, డెఫినెట్గా అటెండ్ అవ్వు. విల్ టాక్. మార్నింగ్ టైమ్ ఎలా ఉంది అంటేనా పిల్లలకి క్లాస్తోనే సరిపోతుంది. సో ఐ కెనాట్ కమ్యూనికేట్. సారీ. ఈవినింగ్ at 7:30 I will take the live. Rolex will meet at 7:30 today. Thank you for supporting. Thank you so much. You too, congratulations, because you are also family member, right? Thank you.